And the nice thing about conjugates are the exact same binomials, but one has a plus sign between, one has a minus sign, is that those two will cancel. So if I add those together, that gives me a negative 20. So the product of my two roots happens to be negative 5. Now the sum, if we add our two roots together, the positive square root of 9, negative minus square root of 29 just cancel. So I get negative 6 over my common denominator, which is negative 3. Okay? So I want you to remember this. I'm going to write it on the next page. We started off with the equation x squared plus 3x minus 5. And the product of the roots ended up being negative 5. And the sum ended up being negative 3. So remember that. So we're going to write that down on the top of the next page also. We started off with x squared plus 3x minus 5 equals 0. And the sum was negative 3. And the product was negative 5. So I'm just going to try to remember that for later on. So next, I'd like you to take this equation and solve it by factoring. And then find the sum and the product of the two roots. Okay, if we factor this, x squared is 15, and we want this to be negative 2x when we're done. So I have an x and an x. 15, to get that I need to use the 5 and the 3. So 5x and 3x. I need a negative with the 5, so that this will add up to my negative 2x. So this factored into x minus 5 times x plus 3 equals 0. So, using the zero product property, then x minus 5 would equal 0, or x plus 3 would equal 0. So my solutions are, I add over the 5, and I subtract the 3. So the solutions you should have received were positive 5 and negative 3. And the sum of those two would be 2. And the product is negative 15. Okay. So next, what if the roots of the equation are negative 8 and positive 6? What would the sum of the product be? So this one's a little bit easier because they already found the roots for us. So if the roots are negative 8 and positive 6, the sum would be negative 2, and the product is negative 48. But now, they want to know what's the possible quadratic equation with these roots. So if we look back at the last problem, when this was a 5, it came from the parenthesis x minus 5. And when it was a negative 3, it came from the parenthesis x plus 3. So on this problem with the negative 8, it must have come from an x plus 8. And the 6 must have come from a parenthesis that was x minus 6 equal to 0. And if I box this out, if I multiply it out, I'm going to get x squared, 8x, negative 6x, and a negative 48, which gives me x squared plus 2x minus 48 is equal to 0. So again, we're looking for some kind of a pattern here. And so we're going to look at one more problem down here. And it asks you what your roots are r sub 1 and r sub 2. What's the sum of the product? Well, the sum would be r sub 1 plus r sub 2. And the product would would be r sub 1 times r sub 2. So that's not too bad. But it wants to know what would the possible quadratic equation look like with these roots. So if we go back and look at this problem we did originally, notice the sum of -3 and the product of -5, and see if you see those numbers in the equation. On the next problem, when it was x squared minus 2x minus 15, we had a sum of -2 and a product of -15. Do you see those numbers anywhere in the equation? And on this last one, we generated the equation, but do you see the sum and the product numbers anywhere in that equation? And it looks like the constant number is always the product, and that was the product, and that number there was always the opposite of the sum. So let's see if that works in general. So here in this equation, if my roots are r1 and r2, it would have come from the equation x minus r1, x minus r sub 2 is equal to 0. If I multiply that out, you would end up with x squared minus r sub 1x minus r sub 2x plus r sub 1 r sub 2. And if I do a little bit of factoring on that term, I end up with x squared. I'm going to factor out the minus sign. That would be r sub 1 plus r sub 2, and I also factored out the x. So I factored out the x's and the minus sign. Let's see if I make that plus sign look better. Plus r sub 1, r sub 2. So it does turn out that the quadratic equation is x squared minus what the roots add up to times the x plus the product of the roots. And that's what I have on this slide to kind of explain a little bit or wrap up. The product of the sum of the roots of the quadratic equation, x squared plus bx plus c. Notice this only works if your coefficient of the x squared is 1. So we might have to divide that out first. But it works if it's an x squared plus bx plus c equals 0, and r sub 1 and r sub 2 be the roots of the quadratic equation, then their product always turns out to be the c value, and their sum is the opposite of the b term. So in other words, that same equation that we just got on the last problem. So in this example, if they just want you to find the product and the sum of the roots of this equation, first thing I need to do is make it a x squared, not a 2x squared. So x squared plus 3x minus, obviously that's 7/2 or 3.5, whatever you'd like. So looking at this, can you tell me what the sum and the product of the roots are without actually solving the equation for those two roots? So just to double check now, the sum is the opposite of the b term, so that would be -3, and the product of the two roots are the c term, which is -7/2. Okay, so next. This time I gave you the two roots. I'd like you to go backwards and find what equation, or at least a quadratic equation, that would have those roots. So one way to do this would be to find the sum and the product. So the sum of the two roots would give me 1/2. And the product, so 1 plus the square root of 5 divided by 4, 1 minus the square root of 5 over 4, gives me a denominator there of 16. If I multiply out the numerators, so 1 plus root 5, 1 minus root 5, would give you 1. Root 5, I'd have a negative root 5, which again